So determining a molecular formula. There's basically two ways they're going to ask you to do that. A simple way like this, where they're giving you the empirical formula, and they're giving you the weight of the true formula. That one should be, you'll see, is a really simple way of doing it. And then the second example we'll use, you actually have to calculate the empirical formula. You have to get to the first point here, and then you use the information they give you to get the second part. So, you know, it's something that you've already done, calculating empirical formulas. You may not be really well versed at it, but we'll see if we can't get you there. So, it would be nice if I knew how to pronounce that. Mesotoniol. It's a hydrocarbon found in crude oil, has an empirical formula of C3H4. And we said yesterday the empirical formula is basically the simplest whole number ratio, right? So we could double that. It could be C6H8. It could be C9H12. We don't know what the true formula is. But we do know that the true weight in grams per mole is 121 grams per mole. So, simply put, you're going to take your molecular weight that they give you, and you're going to divide it by the empirical formula weight. That's all, and you're going to find a multiplier, shall we say. So they told us that the true weight of this substance is 121 grams per mole. And all we do now is find the molar mass of the empirical formula. So 3 carbons at 12 each is what, 36? 12 times 3 is 36. We're just rounding them off. And each of these weighs 1, so that's going to be what, 40? Basically, somewhere around 40, a little bit more than 40. So what is my multiplier going to be? 3, right? So the true formula, the molecular formula, is 3 times greater than the empirical formula. So my answer is going to be C9H12. Okay? We took the true weight that they gave us in the formula, this 121, and we divided it by the empirical formula weight, which we determined to be 40. And we found a multiplier. Just like anything else with a multiplier, we always want the bigger number on top. I don't want to figure out it's 1/3 of the other, right? It's too complicated. Simple, I mean, it's not overly complicated. The only time it becomes more complicated is when you first have to do and get your work to that empirical formula, and then you have to do this as the second step. Okay? Questions on that? Okay, so let's do one that's joined together. Ethylene glycol. It's used in automobile antifreeze, is 38.7% carbon, 9.7% hydrogen, and 51.6% oxygen. So first question here is, what is the empirical formula? So we did that yesterday. We took the percentages, we assumed it was out of 100 grams to make my life easy. Okay, and so we're going to take 38.7 grams of carbon, and then we're going to take 9.7 grams of hydrogen, and we're going to take 51.6 grams of oxygen. We're going to change them all into moles. Okay, so I'm going to slide this up a little bit. because we don't need that information anymore. And I know I'm going to be going through this pretty quick. We did this yesterday, right? So we're going to change grams to moles. 1 always goes in front of the mole. Carbon weighs 12.011 grams per mole. And the thing is, we'll be doing this so many times, you'll get to the point where you almost memorize carbon and hydrogen because you're going to use them so many times. Hydrogen, again, grams go on the bottom, moles go on top. 1 goes in front of the mole, it's 1.008. And then for oxygen, grams go on the bottom, moles go on top. 1 goes in front of the mole, 15.99. You could probably round that one to 16 to be proper, but we didn't. And you put those in our calculator. Yes, ma'am. You got the first one? 3.22 moles of carbon. Good. And then the second one should be somewhere a little over 9, probably. Yes, ma'am? 0.62? Okay. If someone else wants to give me the third one. .22. Oh, we're going to have nice numbers. That's very nice of them. So this is not the final answer yet, right? Just kind of circling these so we can kind of set our focus on those three. Those are how many moles of each we would have if we had a 100-gram sample. Are y'all any questions about this part before we take the next step? And so what are we going to do next? Divide by the smallest, okay? So you divide this by 3.22, 3.22, 3.22, and I get 1 carbon. We should have what? 3 hydrogens and 1 oxygen. So that will get us our empirical formula. So we did that yesterday. This is kind of a good reinforcer for that. But so we found the first question. What is the empirical formula? The empirical formula is CH3O. That's the empirical formula. The next step is, what is the molecular formula? So we learned that step today. So we take the molar mass that's given for the true formula, which is 62.1, and we're going to divide it by the molar mass of our empirical formula. Okay, so what do we have? 62.1. So let's give us some room. So we have 62.1. That's the molar mass of the true formula. And this is our empirical formula mass. So 1 carbon is about 12. 3 hydrogens would make it, what, 15? Because they're each 1. So basically we have 12 plus 3 for my 3 hydrogens. And then we have 1 oxygen. Let's just say it's 16. Gives us what, 31? Adding all those together. So 62 divided by 31 is a multiplier of 2. So the true formula is going to be C2H6O2. That's our real formula. Okay? That's it. Yes, ma'am. This is 1 carbon. This is 3 hydrogens. That's okay. No, I don't. The problem is sometimes when I go real fast, as you're writing stuff down, you don't always have time to kind of soak it in and look for yourselves. And I'm trying to get us through so we can get your chewing gum weighed, and so, okay.